This conference will now be recorded.
All right. Today we will get started with IKE V2. In the previous class, we were discussing everything related to IKE V1. We tried site-to-site, VTI, proxy-based or route-based VPNs, and then we looked into DM VPN as well. Today we will look into IKE V2. There are a few differences, but overall objective is the same. We are basically creating a VPN tunnel, underlay, overlay, but only thing this time the protocol that we are using is little higher version, higher standard. IKE V2 it is going to be. The first difference we observe is the cipher suite availability. In IKE V2, the cipher suites which are available for use are very high standards than IKE V1. Like here we see SHA2, SHA3, SHA256, SHA512, DH groups 19, 20, 21. We see very high standards available. But again, most of the implementations I have seen even today happening on IKE V1, they are good enough. But if you want stronger than IKE V2, but most important, your hardware should support. I'm not sure if you have observed any firewall devices. Usually when you look at any firewall device like Palo Alto or Cisco, they clearly specify the throughputs. They clearly specify the throughput. If you are using a firewall, clear text, what is the throughput? Just say for an example, the throughput is 300 Mbps. If you implement VPN, the throughput reduces by half at least. Check out most of the firewalls, this information will be given. So you can observe as you bring the VPN, the throughput reduces almost by half. So imagine on this, if you are bringing in IKE V2, it would be more resource used, and more burden on the CPU. So things can become little slow. So you need to choose the right hardware for it, right hardware. As per the software in Cisco supported IKE V2 right from iOS 15 and above. They have supported this feature. Hardware wise, you can use any hardware available, latest hardware which is available for IKE V2, but I would say look for a little higher end devices which are quite capable to do that job. So that's the first point. They are in high standards, their CPU memory usage are going to be quite high. The second difference, operational. Completely different in that way. Meaning the negotiation part is very, very similar. The negotiation, like if I say what we are negotiating the proposal, then we have the DH keys, those will remain same. But the difference that we see is in IKE V1, we use something called main mode or aggressive mode. Then we use quick mode. There are 6 messages here, 3 messages here, 3 messages here. Those have been changed. There is nothing called main mode, aggressive mode right now. That part is different. So let's have a look on that. I have a screenshot from Cisco's website. One of the best comparison I found in Cisco comparing IKE V1 with IKE V2. So if you look at here in IKE V1 and V2 comparison, this left side we are aware, phase 1. The example given here is main mode. There are 6 messages. From the 5th message, the encryption starts off. And then here is the quick mode. There are 3 messages given here. On the right side, what you see, IKE V2 comparison. The messages are same. If you see, they have highlighted it very clearly. But if you look at the names given, they are calling this as IKE SA initialization. And in this, there are just 2 packets exchanged. By these 2 packets, keys are derived and the encryption starts right from here. Whereas in this case, there are 4 messages sent. But the one message that you are seeing here is carrying packet number 1, packet number 3. In packet number 1, I am sending a proposal. In packet number 3, I am sending the DH key and the random data. Both the packets are carried in one packet right here. So this is what I said. The negotiation is same. They have reduced the number of packets. They have given different names to it. So this is what is called as SA initialization. We exchange this. By this, the keys can be derived, you know very well, and encryption can start right from there. And the third and fourth message, if you see, it's basically we are carrying the hash packet and the IPsec proposal. Both these packets are carried in one. Hash and identity is what was there in the 5th and 6th packet. Then the quick mode comes, which carries the IPsec proposal. Both of these are carried in a single packet and finishing the job. So there are just 4 messages used. So that's called IKE authentication, they call it here. Just by 4 messages, a tunnel is created, your VPN is up, ready to be used. That's it, it's done. There is something called as child SA. If you see, there is something here called as a child SA. Nothing but if you add a new subnet, later on you're adding a new subnet and you're expecting a new VPN tunnel to be established for the subnet, that negotiation is referred as child SA. A new tunnel gets negotiated for a new subnet which is coming in, child SA is created, and you're ready to communicate. So that's how the comparison is. This is how the difference is between IKE v1 and v2. Hope it's clear. If you have any questions, let me know. Messages are the same, only the names, the numbers have changed. Okay, I guess it's fine. Configuration, definitely a change. There's a lot of change when it comes to the configuration part. I have the configuration here in the notepad. The initial configuration, there's a huge change. Takes time to memorize it, takes time to remember it. The lengthy configuration when you compare to IKE v1. Let me go through, try explaining you what is there in the configuration. So in this, there is this first configuration which is called as proposal. This is the name which is given here. This is an IKE v2 proposal, and in the proposal there are 3 parameters defined. This is very similar, partially similar to ISA-KMP policy. If you remember, in ISA-KMP policy, you define encryption, you define authentication method, and you define the hash. And then you give the DH group and you give the lifetime. 5 parameters you give. Out of that 5, right now the 3 are here. DH group is there, hash is there, encryption is there. Encryption, integrity, and group. And the best part here, if you remember in ISA-KMP policy, I said you can create multiple policy 1, policy 2, policy 3. When a proposal comes, we check policy 1 doesn't match, then we check policy 2. If it doesn't match, we check policy number 3. Instead, here they came up with the option encryption, first option, second option, third option. So whatever the policy is coming in, we look into this one of them. One of them is matching, we are happy. If first the triple DS matches, fine. If not the second, if not the third. So we have this option here rather than creating multiple policies. So that's proposal which comes. Similar, but the name is different. The next one that you are seeing is IKE v2 policy. Now again, this is where people can misunderstand that this policy refers to ISA KMP. No, this policy is basically referring to your local IP and the proposal. What is your local IP from where you will initiate the negotiation, and what is the proposal that we are supposed to use? So imagine if you have a router with multiple interfaces and you want to establish a VPN tunnel here using a different policy, and here I want to establish a VPN with a totally different policy. I can create two proposals and call this proposal inside the policy. So one IP will have one policy, the other IP can have a different policy. So per interface, you can define what kind of policy or proposal you should be using. So that is something new that we see, where we are mapping the local IP and the proposal we have. The third that you are seeing, not new. In IKE v1 also we have a key ring, but we use it especially when we have a VRF. But in IKE v2, using a key ring is mandatory. Key ring is an option to specify your pre-share key. So in this, you need to define a peer name. Just for your identification, any name, it is not a host name. It is just your reference. You can give any name, client, spoke, whatever you want. And then you give your local IP and you give the remote IP. And then under that, you can specify the pre-share key. What is new here, I observed in IKE v2, the pre-share key for local can be different, for remote it can be different. Like imagine you're forming a tunnel between two routers. This guy might be using the pre-share key A. This guy can be using the pre-share key called B. Very much possible. We can create a tunnel. Only thing when you configure, make sure you configure local is A, remote is B on this router. On the other router, you configure local is B, remote is A. So you can have different pre-share keys in this way. It's a facility in IKE v2, in IKE v1 we don't have. So that is something different that we see in IKE v2. But pre-share key is something common. So that's where your pre-share key is coming in. So you have proposals similar to ISA KMP policy. Then you have a policy which is binding an IP with the proposal. You have a pre-share key. And the next thing which comes is an IKE v2 profile, a final step where you are finishing the first part of the configuration. I'm just comparing to IKE v1. First part of the configuration we had was ISA KMP. So all these are related to it. So this is the last part in that, where you create a profile and specify remote IP, local IP, and then you mention the authentication method. In our example, we are sticking on to pre-share key. And what is the pre-share key? Where is it? It is in the key ring called Cisco. And then you see the lifetime. Coming back here, I told you ISA KMP policy, there are 5 parameters. 3 are highlighted here, 2 was missing. Authentication and lifetime, which is here. Authentication method, pre-share key, lifetime is right here. So all 5 options are used, but they are in different places they are. this part is what is different. Remaining is the same. You have IPsec transform set, you have access list, and then if I scroll down, there is a crypto map. The second part of the configuration is same. IPsec part, crypto map part will remain same. Only the beginning is little complicated here. Any questions, anything, let me know. You can see the access list and you can see the crypto map. They are very, very similar to IKV1 that we configured. All right. So I have a topology where we can test this configuration. I just have to probably modify my access list 10 and 192 I have. Okay, 10 and 192, I think the first line is sufficient. And the interface is S2/0. S2/0, peer IPs are fine. Okay, so I think I can use this configuration on router 1. Just make sure iOS 15 and above you are using for IKV2. This is a site-to-site VPN configuration example right now. In this, first of all, I need to be, okay, let me check IP address first. All right, let me create a default route. Done. And now let's go ahead. Okay, that's done. Now router 2. Okay, let me create a default route. And just do some modification here now. Here the local IP would change to 2.2.2. Here the local IP would be 2.2.2. Remote 1.1.1. Remote 1.1.1. Local access list, I have to just reverse this. Set peer. Okay. So now I can just copy paste this configuration. Okay, let's check out. Let me go ahead, do a ping 10.1.1, source it from 192.168.1.1. I see it's working. If I can check show crypto, IKV2 SA. So here is the IKV2, like phase 1 tunnel. You can see the local IP, you can see the remote IP, and you can see what proposal was accepted and what parameters were used, what is the lifetime and what is the active time. So it's a very nice, the outputs are very nice when you look at IKV2. Show crypto IPsec SA, this is very similar to our previous IPsec. There is no difference. The difference happened in IKE. The IKE part got changed. IKE is basically the one who does the negotiation. That negotiation part has changed, but the IPsec protocol is the same. So that remains the same way. That SPI number, all that logics will remain same. So you can see the output right now. Okay, so I'll share the configuration. You can give it a try. I would like to restart this router and show you something. Let me restart it. Meanwhile, any question, let me know. I'll share the configuration. Try it out. It's a simple site-to-site VPN. What I want to show you here is Cisco has made little easier, like as we discussed, it's little lengthy. We need to remember them. You need to create a proposal, policy, keyring. It's little difficult. Cisco has made it easier for us by doing something called smart defaults. Cisco has created smart defaults. There are some defaults available. If you're okay with it, you can go ahead, use it. If you're not okay with the given option, you can even modify it. I'm going to show you now. So your job can become very easy in that way. So here, let me show you the smart default. So this is a router just rebooted, default, factory default like. In this, if I try show crypto IKE v2 proposal, you can see by default there is a proposal given to us. In this proposal, you can see there is the set of protocols chosen. You can see AES is there, integrity, SHAs are there, DH groups are available. If you are okay with this, you don't have to create a proposal. If you say, no, I'm not okay with it, I need triple DS. All right, why don't you modify this one? You can go ahead, say crypto IKE v2 proposal, and the proposal name is by default default. Under this, you can specify the encryption. I would like to have triple DS as well. I would like to have all these as well. Now, if I go back, check, I can see the proposal here. You don't have to create the proposal again and again for your multiple VPN tunnels which come up, right? Second, show crypto IKE v2 policy. There is a default policy created with matching any local address. Any VRF, any local address proposal, it is referring to the default proposal which is previous. So there is a proposal for you, there is a policy for you. You need to be creating the key ring, obvious. Pre-share key is your duty. You need to be creating a key ring and you need to be creating a profile. Profile and key ring is something custom. So you need to be creating them based on your requirement. So proposal can be avoided, policy can be avoided, even IPsec transform set can be avoided. Show crypto IPsec transform set. If I check, there is a default transform set which is available here. So there is a default which you can see ESP AES and SHA HMAC. The name is default. If you're okay with it, use it. If not, modify if you want it. So there is an IPsec proposal available. So your job is to create the key ring, create the IKE v2 profile, interesting traffic access list, crypto map, apply. Makes your job easy. So that's something in Cisco devices you find the smart defaults. These are referred as smart default. which can be modified based on your requirements. You can modify them. So this is one benefit we see. Any questions? All right. I have another topology here. In this topology, I'm planning to go ahead, create IKE v2 based VPN. My requirement is something like I would like to create VTI. And I want to make this as hub and spoke right now. I want CSR1 to be the hub, CSR2 and 3 here to be the spokes. And I wish to create a tunnel between hub and spoke using a VTI method. Similarly, create a tunnel here using a VTI method here. I'm just telling you what I want, what is my requirement. Like VTI, I want a tunnel. It should be hub and spoke tunnel right now. For this, if I think of VTI on my CSR router, I should be creating tunnel 0 for one tunnel towards CSR2. I need to create one more tunnel which will be towards CSR3. If there were many more, I should have created multiple tunnels. So it makes the job difficult here, creating multiple tunnels. Not only on hub, even on spoke, I need to create tunnels. Right? So it's a little difficult, point one. Just going back to the older method, in IPsec VPN, we had an option called as a remote access VPN. What today we are using SSL VPN or AnyConnect VPN. Earlier days, it was based on IPsec. And in this IPsec remote access VPN, a router could have been used as a VPN client. A router can be used as a VPN client. And this side can be used as the VPN server. And the router can initiate a connection like VPN client. Like how do you do? Probably in your laptop, you have a VPN software. You just type in your username and password probably, and then click on connect. You initiate a VPN tunnel. Very similarly, the router here can initiate it. I'm mixing many things here right now. I'm trying to tell I need the tunnels similar to VTI. Multiple tunnels has to be created. Then I mixed the clients here saying that there is a earlier option like VPN client where a router can initiate the connection. Cisco has merged all these things, and in IKE v2, they introduced an option called Flex VPN. Probably flexible VPN. It's very flexible, Flex VPN. You want hub and spoke topology. You want spoke to spoke also. We can achieve it. You can achieve exactly VTI logic, but in a very simple, easier way we can do. Now, how that happens, I will try explaining, and I will compare to what I was putting across previously. In Flex VPN, one side would become the Flex VPN server. Like this is Flex VPN server. And on a Flex VPN server, we will have multiple tunnels, but the benefit we see, it's automatically created. On this Flex VPN server, we create something called as virtual template. And under this virtual template, we define the parameters. And these parameters are the tunnel related parameter. Tunnel source, what could be the tunnel destination, but in this we will avoid the destination because it's a multi-point now. Tunnel source, what will be the IP address of the tunnel. We define all the parameters on this configuration called virtual template. All right. And on the spoke router, we are going to configure these spoke routers as Flex VPN client, very similar to the olden days where we were doing the remote access VPN in the olden days. We are going to create a Flex VPN client, and this guy will have the server IP. Okay, your server is 1.1.1, and the clients initiate the connection always. Like they are like static tunnels they are. These guys are like dynamic tunnels. So we create a static tunnel, we configure tunnel 0, we give the details, we give the peer, and this guy will initiate. When the connection reaches to this guy, if it is valid, based on the template, automatically a tunnel gets created. This is known as virtual access, we call it. It creates one interface by name called virtual access equivalent to tunnel. Automatically it will create one interface for you, bring up all the settings copied from template, like BGP peer policy. It's basically a policy, it's basically a template. If the other router negotiates, as the negotiation comes, if everything is right, you're authorized, automatically we will create one more tunnel. Like this, I can dynamically keep creating tunnel as and when the spoke comes. So it's like your server is going to be one-time configuration. You just do one-time configuration, everything will be taken care of. And not only this, even the routing part is taken care. In VTI, it's a route-based VPN. Any traffic which is reachable through the tunnel is encrypted. Remember, anything which is reachable via tunnel is encrypted. Even that is automatically taken care here. When we initiate, we send all the networks that we want to secure. So we send 10.1.3.0 is my network. When this network is sent to the router this side, this guy automatically will create a static route, and that static route will be pointed via the virtual interface that we have created. So whenever the negotiation happens, they carry their subnets as well. So those subnets are automatically programmed as a static route, and any traffic going to that destination will get encrypted automatically. You can see different technologies they have put across here. Automation using virtual template, VTI concept, any traffic going out of the tunnel is encrypted, and automatically the tunnels are getting created. Automatically the routes are getting created, and the spoke routers are acting as a client. They are the one who initiate. We configure them to initiate. This is what is called Flex VPN, and we can take one step ahead, creating a tunnel spoke to spoke as well. If the spoke to spoke connection is required, we can definitely do the same thing even on the spoke to spoke logic. One step ahead we can go, like a DM VPN. There is nothing called DM VPN in IKEv2. It's a Flex VPN. You want to do DM VPN kind of logic, go for Flex VPN spoke to spoke. You'll get exactly the same logic. So this is what Cisco calls it as Flex VPN. Probably they wanted to call it as flexible VPN. You can have all these facilities. So it's like many things put together. So nothing is new for us. It's all old technologies, all combined together in a better way. Any questions? Let me know. Okay, I guess it's fine. I have the configuration, and you can observe here. Seems a little complicated, but again, if we start working on it day to day, it becomes easier. So this is the server configuration. In server configuration, AAA becomes mandatory. We are not using any radius or AAA server. We are using local. And here we are basically authorizing you to access the network. Whatever the networks we have behind, you are authorized to use it. So we give a AAA authorization for it. And then we are creating an access list. Whatever the network you specify here, these are the networks sent in the proposal. And you will be creating a static route for it. In our example, it is any, so you will be creating a default route. So because of any, my spoke routers will create a default route. It's very much required in my example, as I'm trying to connect hub to spoke. If spoke to spoke communication should happen, it should happen like this. So better they both get default route. They both get default route. So I have used access list any here. So this access list will be pushed and the clients will create a default route. And this is the one here. This is the push which happens, authorization policy. In this, we are calling the access list created. Push it. Not only that, you have to push the IP or the network address of the tunnel that we are creating. A tunnel will get created. That tunnel interface IP, whatever is there, even that gets pushed. So tunnel IP and your access list will be pushed to the other side. Any question? I'll just hold here. This is the authorization and this is the routes which get pushed when a VPN tunnel comes out. Okay, then as usual, you can see pre-share key. We are using the remote as 000 and pre-share key Cisco. I am avoiding proposal. I am avoiding the policy. That means we are using the default. You can see the keyring. You can see the profile here. Remote 0, local is 11, and we are using pre-share key. Key ring is here. Authorization list has been called here, and we are saying we are using a configuration called virtual template. Currently, there are no tunnels. Tunnels will be created dynamically through this template. So that's the reference made here, virtual template. Then there is IPsec profile created for VTI. If you remember, we create a profile to apply it on the tunnel interface. On this profile, we are referring to IKV2 profile. Transform set, we are using default transform set again. So whichever smart default is available, we are trying to make use of. So IPsec transform set is default, proposal is default, policy is default. And then if you go down, you can observe the configuration which I said. There is a virtual template created. This is going to be tunnel. This guy is intern. This is template. Okay, it's a non-working interface. In turn, he creates an interface called virtual access, exactly like a tunnel interface. And that guy will have an IP borrowed from your loopback. Tunnel source will be the physical interface exit, like a GRE tunnel. And tunnel protection will happen by an IPsec profile called default. Simple configuration. If you understand it, simple. But we may have to keep this like a template in future if we have to create a VPN quickly. But this is the logic, very easy, flexible VPN that we have. You can create hundreds of tunnels out of this. So my server can create 100 tunnels by using this template. Like it's like one-time configuration we do. Hope it's clear. And if you look at the client, in VPN client, very similar, AAA, access list, which network you want to authorize it, so that the traffic towards that network can be encrypted from your neighbor. So you advertise it. So 10.1.3.0 we have. Statically, we are creating a tunnel here. A static tunnel is created, tunnel 100, tunnel source, tunnel destination, and then IKE authorization we are creating. We are specifying what networks to be pushed. Key ring is getting created. IKE v2 profile is getting created. And then we are creating keyring. Then we are creating, this is an extra configuration. We are creating IKE v2, a Flex VPN client. Who's the server? This is the server, and you will be using tunnel 100 to connect. So this is the one which will trigger. As you finish the configuration, this will trigger the connection. So it's like remote access VPN link. Client will initiate, and the server will dynamically create a tunnel like VTI. So many things are mixed here, and they have got this excellent option, Flex VPN option. I'll share the configuration so that you can try it out. I'll probably even share this file as well. As of now, to test, let's go ahead, configure it. Let's test this. So here I have Flex server, show IP interface brief. IPs are configured, loopback is there. Show IP route underlay routing should be there. I have used static routes to get the reachability to 222 here and to get reachability to 333. Static routes are there. So I have done this, and please use CSR. I have tried in viOS 15, I have tried, but it doesn't work. I was successful in CSR router. So if you are trying to practice, please use CSR router to use this. So the basic config is there. I will try to ping 222 and 333. I should be able to reach them. Underlay should be perfect. 333. Okay, let me check once. Let me open 2 first. 3. In this guy, show IP route. I do see the route. Show IP interface brief. 3331 it is. Okay. Wrong IP. Okay, that line. Fine. So that's all good here. So the configuration, I can go ahead, server. Let me check if anything to be changed. 111 IP remote. I think it's all good here. I can copy paste it. Okay. And just have a look here, show IP route. We have the routes as we saw previously. Show IP interface brief. This template will appear, and just remember the template will always be shown as down. It will in turn create another interface called virtual access. That interface will be the working interface. This is just a template. So it will remain down, don't bother about it. It's just a template. And now the tunnels will come up as and when the clients come in. So the client that we will configure, this is right now 10.1.3. So it is the second spoke actually. Okay, let me copy, put it on this second guy. CSR3 that would be, and here you can see as I finished the config, tunnel came up, and as the tunnel came up, the Flex VPN established a connection. It initiated, dialed, got connected, it is up right now. So if I go to CSR1, you can see there is one interface coming up called virtual access. Show IP interface brief. A virtual access came up, which is up right now. So that's one tunnel right now. It doesn't create a tunnel interface. Instead, it creates a virtual access, but it is equivalent to tunnel. And then show IP route static, let me check. And in this, you can observe automatically there is one route coming up, 10.13.0. And this network is reachable through virtual access 1, VTI logic. Any destination reaching through that virtual access is encrypted. And you don't have to worry about that routing part. If you can carefully prepare your access list, when the VPN tunnel comes up, automatically these routes are getting created. So you don't have to worry about an overlay routing. What kind of overlay routing should I do? So you don't need that EIGRP, OSPF, what we tried. So it's taken care by automatically injecting static routes. Let's do the same for the other spoke. Only the subnet will change as 2 here. Okay, even this looks fine. And now if I try to ping, let me see the diagram. I'll try pinging spoke to spoke. Ping 10.13.254. Source it from 10.12.254. I'm able to ping. And show crypto IPsec SA. I can see the encryptions, decryptions which are happening here. So this is the Flex VPN which is available. So you can use them. It's very simple, automated. Best part is a lot of automations done. If you have too many tunnels to be created, Flex VPN is the best, easiest way that you can create. Any questions, anything? Let me know. Next, I'm going to start with SD-WAN. So before I start with SD-WAN, if you have any question related to this IPsec, anything, let me know. We can discuss. Okay, I see Satish is connected. Satish, are there? You're able to hear me?
I can hear you, John.
Okay, Manoj, thank you. Okay, so I think we will take a 5 minutes break here. After 5 minutes, we'll come back, discuss for SD-WAN. Not straight start SD-WAN. We'll first discuss why we need, what is the logic behind it, what is the basic requirements, all those we will discuss. So we'll start with some basics. So we'll take 5 minutes break. After that, we will continue. See you all after 5 minutes. Hello everyone, I'm back. Hope you're all there. I'm audible. Anybody has experience on SD-WAN and want to share what is SD-WAN, why we use, what's the benefit, anything you're aware with SD-WAN, let me know. No? All right. Let me go ahead. Before I enter into SD-WAN, let's discuss on the topology that we are seeing right here. Imagine we have been given a task to implement this topology on WAN side only. Our project is supposed to be only on the WAN side. These routers which are coming in the rectangle that I have placed, those are the routers which are facing the WAN, and we are responsible to bring up the connection between these sites. There are 2 data centers. There are 3 branches in the bottom. We want to have connectivity between all, and we are responsible to configure. The design is right here. We are going to have 2 WAN circuits. We are going to have connectivity to both. Now you can suggest what kind of configurations, what plan we can do, how we can use these WAN circuits, maybe primary, secondary, load balancing, whatever. You can give us the suggestion and we can implement it. So in this, any of you, any opinions like what we can do? If I have to configure the setup in this, the design which I have, if I have to configure, what all should I configure? How should I be configuring? Any ideas? If you can just give your opinion about it, let me. Not sure if Pawan is speaking. I can see the mic unmuted, but I can't hear you. Anybody else? What could be the suggestion? What we can try? Okay, let me go ahead. There are different ways we can do. One, let me call it as WAN 1.0, a legacy method where, for example, R11 is connecting to MPLS. So basis on it, okay, let us run BGP here. Internally, let us run OSPF or anything that the enterprise admin chooses. WAN team, LAN team might be different. whatever the LAN team chooses, whether it is OSPF or EIGRP, whatever, then we are going to redistribute OSPF to BGP, hand over the routes to the service provider, and then the service provider will in turn take care. We have learned in MPLS how they do it. That's considered as a legacy method now. WAN 1.0, but there are setups, people who do this still. These setups are valid. We can go ahead use them. But here the challenge that we see, we are too depending on MPLS. There is a dependency on MPLS. The problem in MPLS, if you start looking for some document on SD-WAN, they compare with MPLS and they say, if you are trying to get an MPLS connection, the first challenge will be the commissioning time. You may not get it immediately. It takes time to get the MPLS link. Second, you are too dependent on MPLS service provider. You are completely dependent on them. They are the one who are doing routing for us. They are the ones who have to support QoS for us, multicast support, traffic engineering support, everything they are supposed to take care. We are too dependent on them. But today the world is running on overlay logics. Most of the setups, if you see today, they are all overlay setups, meaning customer controlled. Everything customer decides. He wants multicast, he wants IPv6, encryption, QoS, everything is decided by customer. But here you are too dependent on MPLS. And at your location, if you had a particular MPLS provider and he says, we have these things to offer, we can't offer you anything else, you have no choice, you just need to use it. So you are too dependent on them. That's problems that we are facing here. You are handing over all the routes to the service provider and he is responsible to do routing for you. On the other hand, you have internet. If it is internet, obviously we will think of security. So we may be thinking of creating a VPN, maybe a DM VPN or maybe a VTI or a Flex VPN, some kind of VPN to secure. So we have one side MPLS, the other side internet. There are organizations who use MPLS on both sides. There are organizations who use internet both sides. Certain locations, maybe internet is doing better than MPLS. Maybe the internet speeds offered are better than MPLS. Probably, could be. Certain locations, internet might be doing better. So depending on it, we have the WAN circuits and we have the connectivities. This is the legacy way. Then Cisco came out with a technique saying, why not we implement this setup a little different way? Let's remove the dependency on the service provider. Let's try bringing up everything on the customer side and have maximum control, what we want. That comes the second one, WAN 2.0, and Cisco called it as IWAN, Intelligent WAN. Lot of things to learn. There's a dedicated book available for IWAN. It's a thick book. Lot of things we can learn on this, like especially like when you are implementing EIGRP on a WAN circuit, how you can optimize. BGP when you implement, how you can optimize. Most of the things we have covered, but you can read those books to see exactly the examples given based on the one-off WAN circuits like this. So they are explaining based on a setup like this. In this setup, if you run BGP, what all optimizations you have to do. So specific to a topology, they have explained. So that way we will learn scenario based logic. But most of the things we have learned them, you can just connect the dots, that's it. So it's an excellent book. If you get a time, opportunity to read, go ahead, read. May not be helpful today because SD-WAN is taken over, but still it will improve our knowledge and it can be used in smaller sites. Imagine this is the site we have 5 sites totally, and somebody suggesting SD-WAN, I would say definitely not. SD-WAN for 5 sites? No, that's too expensive. I better go with IWAN. So remember, it's not outdated. A smaller site can still go ahead, implement a technique called as IWAN. So what is IWAN? Intelligent WAN, Cisco came out with certain standards. And in that, the first standard that they came up and they said, you should be implementing called transport independence. Transport independence. This is the first concept you should do when you implement an intelligent WAN. What is transport independence? Transport independence, there are some subtopics under this, and one of them, go ahead, use VRF. Keep customer and service provider network separate. Like here, create a VRF dedicated to MPLS, and you run whatever protocols you want with the service provider. Is it BGP, whatever, choice is yours. Similarly, you can create a VRF facing the internet. Probably you will be creating a static default route here. Go ahead, create it. Keep the routing table separate. Front door VRF, FVRF. Any VRF facing the service provider, it's called front door VRF. Internally, you create a separate VRF, or you can use even the global VRF, that is fine. This VRF is called IVRF, inside VRF. And you run your internal protocol, maybe OSPF, maybe EIGRP. I think I'll stick to EIGRP. That is one more logic of IWAN, consistently one protocol, EIGRP. They say consistently use one protocol so that you will have better scalability. So internally, you run EIGRP, keep routing tables separate, and use MPLS or internet for purpose of underlay or purpose of transport network. Their job would be limited to providing connectivity from one site to another site. That's all. They are not supposed to perform routing for us. They are not supposed to be involved in our routing at all. That is what is called transport independence by creating a VRF. MPLS is very capable, but still they say, let's use MPLS for the purpose of connecting one point to another point. That's it. Future, there are talks, people say there might not be any MPLS. It all depends. Let's see how the 5G comes up, how these new networks are coming in. And if those work well, I think MPLS might vanish, but it will take some time. It will take few years at least, all these things to happen. But right now we can see they are just using MPLS to provide connectivity. We are not using any of your services. That way, you can tell your service provider, if you don't give me a good service between these 2 points, we will replace you. And it won't hamper our connection. A quick replacement, I will change the service provider to some other provider, my setup will remain same, because we are running customer controlled overlay logic. So we are not dependent. Service provider will be very scared. Say, okay, I should not lose the customer. Customer is important then. So they will try to give us best services. If not, we are ready to change. Very easily we can change them. Earlier days, it was very difficult. If you are not happy with the service provider, If you want to change, you have to find a new one, you have to do P2C routing, redistribute, lot of things. It was not that easy, right? So that's one point, transport independence VRF. Second, bring up overlay. You create an overlay between each site over the MPLS, over the internet. And in this, Cisco chose DMVPN, as it provides an second important part that we look here, security. Transport independence, security, second important factor. DMVPN provides us security as well. It gives us the overlay, as well it gives us the security. And DMVPN, by now you know, hub and spoke, spoke to spoke dynamic tunnels, spoke to hub static tunnels. Very easy, dynamically they come up. And the hub routers are one-time configuration they are. You can keep adding up your spokes, not an issue. So DMVPN was widely used in Cisco during this time when IWAN was popular before SD-WAN. Even now, as I said, if it is a smaller network, like 5 to 10 sites, it's good enough. You can still go ahead with IWAN, not an SD-WAN. So DMVPN was used as an overlay and a consistent routing protocol, a consistent routing, nothing but overlay routing. Now this overlay routing will not be used just on the overlay, even inside your network. There is no need on overlay, you run EIGRP, internally OSPF, then redistribute. If you can avoid redistribute, it is nice. Keep it simple, keep one protocol, keep it simple, and you will have the easy troubleshooting, easy scalability. And EIGRP is good. You can easily summarize on hub routers and you can do a lot of optimization. So transport independence talks about VRF, talks about overlay, talks about consistent routing, overlay routing, single routing protocol for our networks. When we connect with the service provider, maybe BGP, maybe static route, but our corporate networks run by a single protocol. Security, a lot of other things can be added. Like you can keep a firewall, you can keep an IPS, blah, blah, blah. You can add up as much of security you want to on your data centers or on each branch. If each branch is trying to have internet access directly, that is another concept they tried working called DIA, direct internet access. Nowadays, most of the services we do on cloud. We have SaaS services, on cloud service. So customers might need access to internet directly. Instead of going to their data center, then accessing the internet, you can directly access. When you do that, security is very important. You can even think of having cloud security, like Cisco Umbrella, Zscaler. You can use cloud security as well. So direct internet access was another concept which was well thought, not only for customer, even for guest access. If there's any guest coming to your network and they just want to have internet access, we can do DIA, and we can include some AAA settings. When the guest comes, we can give them a temporary username and password, authenticate them, provide internet access for a day or 6 hours or 5 hours. So we can include a AAA and we can work on it. So that was another option which was there. So transport independence, security, direct internet access. There's another important that we are coming up. Before I come there, if you have any question here, let me know on the modern design using IWAN. So if you get an opportunity to work on a small network, you can think of using these techniques instead of SD-WAN. If it is a very large network and it's a growing network, SD-WAN suits, then fine. I'll come to it SD-WAN also now. But this is the IVAN techniques which we can implement. Any questions, let me know. I'll hold here before I go to the next option. Okay, I guess no question. The other option that we look here in IVAN, intelligent path control. Again, basis on your requirement. When you say there are two tunnels, one through the MPLS and one through the internet, you have two tunnels. How would you like to use these two tunnels? There are different ways to use them. One, you can use primary, secondary. The other way that you can use is ECMP. Third, you can do some PBR. Fourth, you can do something called intelligent path control. These three options, whatever we discussed, they are all static methods they are. You fix it up. Okay, this is primary, this is secondary, fixed. Primary fails, secondary will come. Or you do PPR saying voice traffic will use this path, web traffic will use this path. You are fixing up static methods there. So Cisco came up with an intelligent way, dynamic way, and they called it as PFR, performance-based routing. Another important part of an IVAN. But again, choice. Customer should be choosing based on the requirement. If customer's requirement can be satisfied by primary, secondary, you're fine. But if customer's satisfaction is not happening by this, we are going to use PFR, fine. So I'm not saying you should use PFR. No, not at all. Which is called in SD-WAN as AAR. Application aware routing it is called. Cisco called it as PFR earlier. And I have seen this, it's now been 14, 15 years, I'm seeing PFR. So I'm not saying everybody should use it, but when you have a situation, you can use them. What is it? I'm going to tell you. Earlier version, when Cisco came out, probably like 14, 15 years back, it was called OER, Optimized Edge Routing. Then they renamed it to PFR. The current version available is PFR version 3. It has gone with drastic changes they have made. The earlier version PFR, if you work, horrible. Every router has to be configured, lengthy configurations. In PFR version 3, they have tried improving it better, but not better than SD-WAN. That's where SD-WAN stands, automation. Here it is, they have simplified it, but still it's a lengthy configuration that you have to do. So I'll not get into configuration part, I'll just tell you the logic, how PFR works. What's the logic of PFR? So we have two tunnels right now, one through MPLS, one through the internet. Now customer says, I have a voice traffic. The voice traffic can use any tunnel, I have no problem. What I'm looking at is the values. Voice traffic should have a packet loss of 1%. Delay should be at about 50 milliseconds. And the jitter should be at about 50 milliseconds. Just an example, this is my requirement. Any tunnel which can offer this, I'm good to use it. Dynamic method. I'm not fixing it. When you fix it up, when you say voice traffic, you always use this path. Imagine if this path becomes worst due to some issue. This path is congested, it's not good. Can you shift? You can't dynamically shift. Probably you should do a manual intervention. Manually, you need to change it. So in PFR, that benefit comes dynamic. So you have your requirement. So then we run PFR. What PFR does, it starts collecting, it starts measuring and collecting values from each tunnel. Okay, we have MPLS tunnel. In MPLS tunnel right now, the loss is 1%. Delay and jitter is at about 30 milliseconds. In internet tunnel, I see 1% loss. I see 60 milliseconds delay and jitter. So PFR will announce MPLS is right now in policy as per your requirement. Internet is right now out of policy. So voice traffic can use MPLS tunnel. And these measurements keep happening. Maybe there's a time when these values might increase, let's say to 70 milliseconds. These values might improve to 40 milliseconds. Now your PFR says internet tunnel is in policy, your MPLS tunnel is out of policy. Shift the traffic dynamically to this guy. So dynamically the traffic will shift automatically to the internet tunnel. You don't have to do anything here. You have specified your requirement. Basis on it, your PFR is measuring. Basis on it, the routing is changing automatically. So you can imagine the configuration. Measurements are involved, routing management has to be done. Configuration is huge, but in version 3, they have simplified. They have done some automations like one router, we call that as a master router, MR. On that master router, we configure everything, and from there, the configuration gets pushed to all other devices. So Cisco used some automation without any, GUIs or anything. It's a CLI, and they used EAGRP for it. But it's a lengthy configuration to be done on a single router, and they spread this configuration. So like this, dynamically, it is going to choose the path. That's called PFR. That's called intelligent path. Cisco says this is part of IWAN. So when you design an IWAN, you can get this benefit. You can implement everywhere, the choice is yours, but they made like a package. If it is an IWAN, we will do all these things. And one more is QoS. We will talk about QoS later in a separate section, but QoS is a part of it, making sure we will provide quality of service. Your tunnels will have dedicated bandwidth. Your traffics can receive some bandwidth as per your requirement. We can implement those steps. So IWAN talks about transport independence, security, direct internet access, intelligent path control, QoS. A lot of other small things are there. You can do those stuffs, but these are the major pillars, concepts of IWAN. So you can implement, run all these on the design that we are seeing. So that is IWAN that we have. Any questions, anything? Let me know. Okay. But again, the challenge here in a large network, imagine if I have at about like 3,000 sites where I want to implement IWAN. You can imagine the task that we have. 3,000 sites, and imagine in each site there are 2 routers. That means I need to handle around 6,000 routers. I need to handle it. So here it's about the implementation. How much time will it take? How many engineers we may need? Future, if there is any monitoring to be done, how will that be? Any future new implementations, if I have to do those new features, how fast can I implement on 3,000 sites? And any upgrades to be done in future, how that would happen? Everything in this case, operational. We are talking about operational, not capital. Buying the equipments is not a big deal. After buying, using them, operating them, monitoring them becomes a big task. The operational cost, OPEX, is very, very high. Time consumed, more. Number of engineers involved, more. Cost is very high for it. So if I'm implementing IWAN for this scenario, it's a big task. As I said, if it is a small site, it's fine. That is where the third one comes, SD-WAN. I would call it as, it's an old wine in a new bottle. The techniques, whatever we are going to learn in SD-WAN, is the same old techniques, but put it in a new way, that's it. Like FlexVPN. If you look at FlexVPN, the techniques were all the old techniques. They tried VDI, they used the remote access VPN. They tried combining them in a new way, in a simple way. Same thing SD-WAN did it. SD-WAN, they said, let's use all the technologies, like let us use the technology of VRF, let us use the technology overlay, let us use the security technology like IPsec VPN, let us use the technology called PFR. Everything let us use, but let us simplify it. Let us make it in a new way, better way, so that the operational will be different. That's what I said. It's an old wine in a new bottle. The packaging is new. Techniques are all the same. So when you learn, you should be learning how to deploy it. You should not be learning the technologies. You already know majority of the technologies by now. You know the technologies. Only thing you should know how to put it together and apply it. That's what you need to learn in SD-WAN. So they came up with a better way, SD-WAN, how we can do it. Right? So this, if it is a big site, SD-WAN is a real good option. So Cisco offers this. If you look at Cisco offers these options. You have a network, you want to deploy this by CLI, choice is yours. Second, you want to do automation, choice is yours. Like you want to do IWAN, 6,000 routers are there and you want to automate it. Okay, go ahead, automate it. Every router today, most of the routers today in Cisco support automation. You can create scripts, you can run scripts by yourself. So go ahead, use them. But only thing, if you say, I will do automation by myself, you need a dedicated team which does that developing job. So you need developers. They need to develop scripts, test them, time to time keep changing them, bring in new features, especially monitoring, troubleshooting, keep working on it. You need a dedicated team to do that. Or Cisco says the third option, we have automated it and we have put everything into a controller. We have a controller where we have done all the automations, we have the developers, we have put everything here. You just need to log into the controller, give instructions what you want, and the controller will do the job for you. So Cisco tries selling the third one, but it's all customer's choice. But Cisco says we have automated for you, we have made things for you simple, and we are going to support you in future. You just need to pay money, buy the subscription from us. We have a team which will support you. You want to upgrade, or we release some new features, you want some new options, we will work on it. So the third one is the controller. That's where the SD-WAN comes. Right, so these are the three ways you can actually work on: create your own automations, or go ahead, use the legacy CLI, or use Cisco's automation, or the vendor's automation, whichever the vendor is. Okay, hope you are getting slowly the idea. SD-WAN is just making job simplified. That's it. The technologies are the same technologies that we have learned. They are these technologies, what we have learned, they are excellent technologies like OSPF, BGP, MPLS, IPsec VPNs. They're all excellent. All right. Cisco called the controller part, Cisco called it as intent-based networking, IBN. Intent-based networking. If you can go to Cisco website, Google it, otherwise you will see this term used by Cisco. Intent-based networking. What is intent-based networking? They say we have a controller. This controller has been programmed completely, and we provide you simple options like templates or policies. It's like fill in the blanks. They are all like fill in the blanks. They are like the Google Forms. We have created all the templates and policies, possibly what you need. Maybe you're looking at OSPF. We have a template for OSPF, which will ask you a few things like what's the area number you want? Would you like to have some filtering, timers, like this few basic things? What is needed for OSPF to work and optimize it? Those basic things are available. If you are looking at very advanced low level, like we learned so many things in OSPF, if you ask for it, sorry, we don't have it. You want OSPF to come up in a well optimized way, that much we have. So if you are okay with it, use this, otherwise do your own automation. So Cisco has defined these templates. Your job is to fill it up. So as an admin, I need a design and plan in my mind. Intent. You have a design and a plan, tell the controller. Tell the controller in the form of templates and policies. And in turn, the controller will deliver this to your devices. All your devices will be managed, configured by the controller. You just tell the controller what's your requirement. Cisco calls this intent-based networking, and they successfully did this in a data center using ACI. Then they tried doing this on a WAN side called SD-WAN, but they were probably not successful there. And that's where the Viptela comes in. I will tell you more about it. Third, now they have gone ahead, done it on enterprise LAN called SDA or DNA. Your enterprise LAN can also be automated like this. Get a controller, tell the controller what you want. Your controller will do everything for you. It will manage your devices. So SDA is more excellent. They have done underlay configurations are also automated for us. Underlay, overlay, everything gets automatically configured. So that's called intent-based networking. Get a controller, do the job. As of now, what I have seen is these three. ACI, SD-WAN, SDA. Future going, I'm not sure. They may come up for a lot of other things as well. But as of now, these are the three automations we have for data center, WAN, and LAN. Any questions? Okay, let's talk about the SD-WAN of Cisco. As I said, the Cisco's journey, they started with the legacy WAN. They had the legacy WAN, what we discussed, WAN 1.0. Then they had the device called WAS, WAN optimization they had. Then they came up with IWAN. And during that IWAN, they came up with SD-WAN. They said the IWAN techniques are really nice, but doing it by CLI stuff, so they thought we will go with SD-WAN. And they came up with the controller. And the controller that they came up with is called APTM. This is the same controller data center they used. They changed slightly to that enterprise module, they called it. They came up with the controller. And they said, this controller will do everything like IWAN. Everything, IWAN, whatever we are doing, everything this guy will do. But it did not work. Could be a lot of reasons. Like one reason I can tell, these controllers are hardware-based controllers, very expensive. So probably they did not work with the techniques that Cisco was using. Business probably was not good. That's the time they acquired Viptela. Viptela, an organization dedicatedly working on SD-WAN. So these are some top vendors that we see, like we have Silver Peak, recently acquired by HP. Then we see VeloCloud. Then we see Fortinet SD-WAN. They are also really doing good. Cisco, Viptela, Cisco. This is Cisco now, Viptela. And Versa. There are at about like 130 plus vendors for SD-WAN. You name it, most of them are doing SD-WAN. Palo Alto, everybody is doing. But these are some top vendors that we see. So Viptela got acquired by Cisco, Silver Peak acquired by HP. So Viptela was one of the top vendors for SD-WAN. So Cisco got it, and now it's called Cisco SD-WAN, but still the word Viptela remains. So we refer it Cisco Viptela SD-WAN, sometimes Viptela SD-WAN, sometimes Cisco SD-WAN. They're all the same. Probably Cisco is running that as a separate business unit, and he's still using the Viptela words there. Okay, so Viptela is the Cisco's SD-WAN, and this has become popular. It's now in the top. So you could always see they're in top 5, maybe sometimes top 1, so or in the 3rd position. It all depends on the quarter business and new techniques that they bring in. So in SD-WAN, we are seeing a lot of additions. The initial logic was connecting WAN, like VRF, PFR. Then second logic, they came up with a lot of security. Today, SD-WAN not just supports those IWAN techniques, whatever we discussed. That could be like transport independence, VPN security, QoS. They have added a lot of security. Today, the SD-WAN router comes with firewall options, URL filtering, application filtering, IPS, AMP, advanced malware protection. All kinds of security has been added. And they started adding features related to cloud. They are making it SaaS easy, IaaS easier. Then now they are calling SASE. I have not looked into it. I am yet to work on that part. So that's something new that they have added. And then they acquired 1000 Highs for monitoring. there's a huge monitoring demand which comes with SD-WAN. You have thousands of tunnels. Monitoring is very important, and customers are looking at detailed information. So Cisco says, if you want very detailed, we have something called vAnalytics or Thousand Eyes. It's a paid service. If you can go with it, excellent monitoring. So a lot of new things are getting added. By that, they remain in top 1, top 2, top 3. So that's Cisco's SD-WAN through Viptela intent-based networking they are doing. So the logic is get a controller. The controller is going to do all your jobs. Your job is just get connected to controller using a web UI. If you know Python scripting, go ahead. If you know scripting, create a script, push it to controller. If you're not comfortable, use web UI, get connected to controllers. In the controller, they have all the templates, all the policies in a simplified way. Probably you should be knowing high level informations only. You don't have to really know in detail to implement. If you want to troubleshoot, definitely you should know a lot of details. But to implement, if you know high level, OSPF, BGP, high level, that's enough. Just configure, it will deliver the configuration. Every router, probably in 5 to 10 minutes, you can configure these devices. Upgradation will be easy, future monitoring, future configurations, everything will be easier. So that is SD-WAN. Hope you have got an idea. Just an introduction I tried. How the WAN setups were and what we are doing today. We have to further now get into SD-WAN architecture. In SD-WAN architecture, how many controllers we have, what each controller does, how they are working, what happens behind the scene, and how to install and configure. So we will do an lab right from scratch. We will install the controllers. We will install 2-3 sites, and then we will establish connection with them. Then we will try some policies. So we will work on it in the lab in real time. We will do it. But as per CCI syllabus, it's a limited topics. There are a lot of more things to explore, but it's good to start, good to work. It's a good start that we get. You can definitely work on some of your SD-WAN projects, but if you want more, probably you need to learn more later on. Any questions now? Let me know. For today, I will stop here. I will keep the SD-WAN architecture class for the next class. We will discuss that, and then we will also look into practical implementations. Okay, no question, I believe. Then I will wind up here. See you all in the next class. Thank you. Bye.